Namaste. I am Namrataa Kkommineni, also Dr. Namrataa Kkommineni, that is the name after my marriage. I am an assistant professor in physics at the Shah and Anchor Kutchi Engineering College. I first of all would like to thank you for considering me for this prestigious award. Now about myself. I always, since a child, by looking at my mother who was a teacher, aspired to be a teacher. But due to her untimely passing, things became difficult, but still I continued to adhere to my dream. I got admission in the R.K. Talreja College of Science after topping my 10th and 12th into the PCM BSc course. Obviously, physics being my choice, PCM was the best option. I was the only student who in first year know that my honors degree from Mumbai University would be in physics. And finally, I passed in 2007 from Mumbai University with a gold medal. Due to some unfavorable conditions, I had to move to my hometown in Amravati for my postgraduate studies. And I completed my MSc in physics, obviously physics, from Sri Shivaji Science College in Amravati and stood as the third topper at the Sant Gadge Baba Amravati University. I cleared my NET in 2010 and subsequently I completed my PhD in high energy particle physics in 2019 under the guidance of Professor Anuradha Mishra from Mumbai University and Professor K. Sridhar from TIFR. The likes of great teachers like Professor Rangwala, Anuradha Mishra ma'am, Sridhar sir, and several scientists in TIFR and the ambience in Tata Institute of Fundamental Research not only have improved me or enhanced me as a teacher, but also as an individual. These teachers have taught me to be appreciative of all diverse backgrounds, students from all diverse backgrounds, and be humble and polite. And that's what I really admit that I have learned from my teachers. Whenever I go to a classroom, about my classroom teaching, obviously chalk and blackboard is the best thing. But as the younger generations are very distracted, we have to incorporate newer teaching methods to engage their attention. The first thing that I always remember when I go to the classroom is I use very simple language. I always start from something that my students know and gradually take them to something that they don't know so that they don't lose interest. I give them always a lot of examples. So for example, when I am teaching interference, I start from wavefront diffusion interference, which they know, and then take them to thin film interference, which they generally the 12th standard students don't know. The students who have passed 12th standard know only this part. I give them a lot of examples. Then once I have taught the topic, or even before I start, I always encourage the students to keep the lecture interactive by asking a lot of questions, and I encourage them to ask questions. I ensure that I deliver the reading material or content in different formats. I have made concept maps for memorization of derivations and given notes in question answer format. And I also have given them some formula lists so that they can solve problems effectively. I also believe that specifically for my topic, that is applied physics or engineering physics, project-based learning is very crucial. I always try to eliminate the one monotone wherein only the teacher is talking and the students are listening. Obviously that should be some part, but not the whole lecture. I try to make my course fun by adding a lot of demonstrations and making students search for demonstrations. I try to promote healthy competition. For example, the moment I have some topic in class, I'll hold a row-wise competition wherein they have to just come up with the answers of simple 1-mark questions and see whichever row wins. In the whole thing, I believe that I have given more emphasis to the project-based learning. There are many advantages of project-based learning, and hence I have made that a center of my learning activity. Projects help in students in collaborating and eventually help them placements. They help them to think in the direction of problem solving. It encourages creativity in students. Not only that, students become confident about the learned topic. They develop critical thinking ability. Not only that, once they do project management, they also learn project management skills, and this encourages them to learn the subject. This is how I have been making my physics learning very interesting for my students. When I first joined engineering colleges in 2007, I had found that students were treating this subject just a hurdle for going to second year. I found that students were just mugging up the topics for getting passing marks so that they could easily go to second year engineering. When I joined my college, I started working really hard to strive and create different models which I could take in class and explain students and try to make my lecture more interactive, and I tried to encourage the participation of students by holding video competitions wherein their participation was encouraged. And with that, today is the level wherein we have brought companies like CybrainX, which is a company involved in quantum computing. So whenever I teach quantum mechanics, I tell them about the applications. For example, when I am teaching thin films, I have brought an MOU with Surface Modification Technologies, wherein thin film coating industry has given us a lot of projects. And in this way, students really understand the importance of project-based learning and how deeply is physics connected to all the industries, and thus physics for sure is the mother of engineering and not a subject that is merely to be mugged up for passing marks. I have found such different variety of students who were not interested in physics, but after my lectures, physics has become their favorite subject because there is a lot of creativity, a lot of activities going on in class. Thank you.
Hello students, today we are going to study types of interference. You might be wondering that why are there types of interference, because all of you must have only studied that is one type of interference which is called as the wavefront division type of interference, and the example is the Young's double slit experiment. Yes, the very popular Young's double slit experiment. So today let me introduce to you that there are two different types of interference and we will study an example of each of them. First one, the first type of interference is also called as the wavefront division. Wavefront division type of interference. And the second one is called as the amplitude division type of wave. Amplitude division type of interference. Now for whenever we need to study the interference, we need two sources which are coherent. To prepare two coherent sources, it is very necessary that these two sources must be prepared from the single source. So as an example of wavefront division, you will study how does a Young's double slit interference pattern is produced. So let us say that we have a source S. What will happen from the source S? We will have the spherical wavefront produced. So let's say that we have a crest followed by a trough, followed by a crest, followed by a trough, followed by a crest. If this wavefront is subjected or faced with a cardboard which has two pinholes, this wavefront gets divided into two secondary wavefronts, and here we have two secondary sources. Let us say S1 and S2. S1 and S2 are two secondary sources. From these secondary sources, we will again have secondary crest followed by secondary troughs. So here, what we will be observing is that whenever a crest overlaps a crest or a trough overlaps a trough, in that case, we will have a constructive interference produced. But whenever a crest overlaps a trough or a trough overlaps the crest, then there will be destructive interference produced. Let me draw the diagram for you. So let's see these points. So these points indicate that there will be a bright band because the crest is overlapping the crest. When we see the points wherein a crest overlaps a trough and a trough overlaps a crest, at these points we will have dark bands produced. This will lead to alternate dark and bright band production, which will be resulting into an interference pattern. And this pattern is produced due to the division of the waveform. Now let us try and understand a different type of interference which is called as the amplitude division type of interference. How does that happen? For amplitude division type of interference, we need to have a thin film. Let us consider that there is a thin film, and in this thin film, let us consider that a ray of light is obliquely incident. When the ray of light is obliquely incident, this ray undergoes reflection and diffraction. But whenever this ray of light is incident on the other surface of the film, the same thing repeats. The ray of light goes for reflection as well as refraction. And the same thing keeps on repeating multiple times. The ray of light undergoes reflection as well as refraction. The ray of light undergoes reflection as well as refraction. We observe by this consecutive reflection and transmission, we have series of reflected rays. These reflected rays will interfere with each other to produce interference pattern. And we will have series of transmitted rays. Even these rays will interfere with each other to produce interference pattern. The thing is, whenever you have an amplitude of ray A, depending on the reflection and transmission coefficient, this amplitude gets divided into the reflected and transmitted ray. The reflected amplitude is now A times the reflection coefficient, and the transmitted amplitude is A times the transmission coefficient. And when the ray with amplitude AT gets reflected and transmitted, then the amplitude gets further reduced to ATR, where ATR is the amplitude times transmission and reflection coefficient. But here this ray would be AT square because it is transmitted the second time. Whenever this ray with amplitude ATR is reflected back, its amplitude is ATR square. So what is happening here, and when you look at the R, that R2, that ray has been transmitted the second time. So it is A square R. So we will observe that amplitude A has got successive reduction in its amplitude as it goes on reflecting and transmitting, and hence this type of interference pattern is called as amplitude division type of interference, because amplitude is getting successively divided. Whereas whenever we look at this pattern, the amplitude of the rays is unaffected, is getting divided is the wavefront. The wavefront gets divided into two parts to result into the secondary waves. Hence, this method of producing interference is called as the wavefront division type of interference, and this method is thus called as the amplitude division type of interference. Thank you.
Let's talk about my work and achievements. My work includes conducting several trainings and competitions for skill development of my students and fellow teachers and my own self. To encourage my students to study physics, as I said earlier, that engineering students do not take much interest in physics, I try to increase their interest by conducting video competitions since 2019. And you can see, to encourage them, I host their generated videos on our college YouTube channel and conduct prize distribution ceremonies to increase their interest. I also conduct several physics project exhibitions in order to increase the interest of students by learning to do things themselves. We also conducted the physics teachers orientation for the syllabus revision of Mumbai University in August 2019. As a part of training students and teachers since 2015, every year we got a reward in the form of Academic Excellence Award to my college for ranking second in the state of Maharashtra. And also, one of our students has got a Budding Star Spoken Tutorial Alumni Award. During the pandemic, also, we didn't stop. We continued conducting online training sessions. These online training sessions were coupled with several offline training sessions wherein we tried to enhance the skills of our students. Whenever we want to improve the skills of the students, it is important that collaborations are made with industry to bridge the gap between academia and industry. I have created several collaborations in my past 2 years as a research coordinator. These are some companies with which I started the collaborations. These are the ones that I have added, and I'm going to add more. These collaborations give us projects, and participation of students in projects accelerate the skill development of students and also help the teachers also increase their skills. The first project that we delivered to the surface modification technology was measurement using computer vision. For this, we used the diffused light system to measure the tools that are quoted at surface modification technologies. The second project that we delivered to SMT, that is Surface Modification Technologies, was the thickness and the wear calculator. We also developed the PhiloPhysics mobile app, and this app is available on the Google Play Store. In addition to this app, there are other apps also developed by me and my students to help the learning of the students. We have also developed virtual labs during the pandemic with my hardworking team, and the experiments under the virtual lab can be seen here. A beautiful physics virtual lab has been developed. I also got a minor research grant from Mumbai University under which small video tutorials have been created as a website for physics solutions hosted on the Versal app. We have several initiatives under Indian Knowledge Systems wherein most of my students got the grant of 12,500 per month from AICT due to the awareness that I created about Indian knowledge systems. We are also planning to develop astronomy virtual labs for ICAS cell of our college. To encourage the industry projects, industrial visits have fetched a lot of projects and the worldview for my students. We visited Nitya Innovations. We also visited Center of Excellence and helped them set up their website. We visited Laminar Aviation Infotech, which got us a 3D flight simulation project. Not only this, we also encourage our students for participation in social activities as a part of corporate social responsibility. This was the Light of Goodness project that I took up with the help of my students. We also developed a software platform for the Bal Gurukul project of Indian Development Foundation. I collaborated with the General Green Pencil Foundation and contributed to their awareness campaign on smart and sustainable mobility, and also assisted them on menstrual health and hygiene project named Periods of Pride. Thank you.